All right, I think we're rolling. So 1.3, like I said, is all about modeling with linear functions. And basically, our focus is just being able to make an equation for a line in some different situations. That's the whole schmack this time. So we're going to be writing linear equations from a graph, writing linear equations from data, so some kind of information that you're given. And then we're also going to look at determining lines of fit as well as lines of best fit and how we do that. And we're going to use our calculator to help us with that last one. Okay. Now, all of those things are things that you have done before, but like I said, it's worth the review because we're going to talk about lines and use them in the future and that sort of thing. So let's first, before we get into making equations, let's talk a little bit about all the different forms of equations, of linear equations you guys have seen before. So hopefully that's a little familiar to you. Anybody know what that's called? Y equals mx plus b. Okay, what's the m in that equation represent? That's the slope. Hold on, I'll get you there. So that's the slope. What's the b? Y-intercept. So what form is this? Slope-intercept form. That's what this is called. Because those are the two things you need to know to be able to write this equation then. Okay? Okay, so slope-intercept form because, like we said, the m, that's the slope, and the b, that's the y-intercept. Okay, so that's one form that you've studied before of lines. Another one that is probably a little less familiar. I don't use it quite as often, but it's still a valid way to do it. Looks like that. So, anybody remember that one? Remember what the name is? No? Okay, so again, what's the m? That's the slope, right? And the little x with the subscript 1 and the y with the subscript 1, where do those come from? It's not the intercepts, actually. It's just coordinates of some point that's on the graph of the line, okay? So we have a point and we have a slope. So what do you suppose this one's called then? This is point-slope form, yeah. Mm-hmm. Okay, so again, the m is your slope. And then these two coordinates together are the coordinates of a point that is on the line. It can be any point on the line. It doesn't have to be a special one. Okay? So we're going to be using both of those, mainly the slope-intercept form, just because it's easier to work with and it has a lot more uses to it, but might pull out some point-slope form in there too, depending on what we're looking at. Okay? So let's start. We said the first thing we want to do is, if we take a look at a graph, can we make an equation of a line from that? So let's try that first. Okay, so here's our x and y. And let's say we've got a line that's coming up like that. We'll put a couple of points on it. Oops, that should be 0. And this is, let's say, 0, 0, 2. Okay. So let's just do slope-intercept for this real quick. So the two things that we need to know about the line are the slope and the y-intercept to be able to write this one then. So let's start with that first thing, slope. How do you measure slope when you're looking at a graph of a line? Yeah. Okay, so you need to know how far, from point to point, you need 2 points on it, how far up and how far over does it go? Okay, and what do we do with those two numbers then to make a slope? Once we know it's called the rise and the run. You make it a fraction, right? We always say rise over run because that's a fraction for the slope. So in this particular one, from one point to the other, the rise would be 2, and the run would be 3, right? So our slope, so m is equal to rise over run. So in this case, m is 2/3. And sometimes you'll end up with a fraction there that you can reduce, and if it's reducible, go ahead and do it. But we got 2/3 this time, which we can't reduce, so we're done. Just leave it like that. Okay, so we got the m. What else do we need now? The y-intercept. Okay, and what is the y-intercept? 2. It's one of the points I gave you on there, right? It's 2. So the b is 2, right from the graph. Okay, so we know those two things. All we do is copy down that slope-intercept form, put those numbers in, we're done. All right, so that would be the equation of that line. Okay. Now, sometimes you're not going to be given points on the graph that are quite as nice as those two. In particular, the y-intercept. If you're given the y-intercept right on the graph, that's pretty easy because you can just take that number off and use it. But let's say we've got another line. We'll do one here where I'm going to give you 2 points, but not ones that are as convenient for you. And see what we can do with them. All right, so let's say this line is doing one of these. Let's say, like, we know a point over here, maybe that's at -2, 3, something like that. And then maybe another point down here that is, say, like 3, -1. Okay, so we got those 2 points to work with this time. Okay, so we can still do the rise over run, right? We can still get the slope to start with. Okay, so this time, if we start at this one, the rise is actually going down, right, to get to the other point. And then the run would go this way. Okay, so what would be our rise, technically, for this one then? Okay, it's 4, but it's going down. So what would we do then? So just call it -4, right? Okay, so the rise is -4, and what's the run then? It would be 5. Yeah. Take a look at the x values. -2, and then over to 3, right? So you're technically moving over 5. Okay, so what's our slope for this one then? -4/5, right. Okay. Now, last time, we did slope-intercept form because we had a y-intercept and it was easy. We could just take that number and put it in for b. Now, this time, I don't have a y-intercept, okay? And trying to pinpoint where that at is actually going to be pretty hard to do. So instead of going slope-intercept this time, point-slope makes a little bit more sense. Okay, you guys see that? Okay, because point-slope, what do you need? A point and a slope, right? And we have a slope, and we have 2 points sitting on the graph there that we can choose either one and it doesn't matter. Okay, so let's do that instead. Let's do point-slope. Okay, so we got to choose which point we want to work with. It really doesn't matter, whichever one you think is easier. I'm going to go with this one up here. Okay, so there's our slope. Here's the point I'm choosing to use, but it doesn't matter as long as you get one that's definitely on the line. And I'm going to just take all that information and put it in. So in point slope, we said it's y minus y1. Well, that would be this number, right? The 3 is the y1. So y minus 3 equals m, negative 4/5. And then in parentheses, x minus x2. Well, this would be x2. I'm sorry, x1. My bad. X minus x1. So if x1 is negative 2, what am I going to write in the parentheses there? I can do a plus 2, right? So x plus 2. Okay, so if the question asked you to write the point-slope form of the equation, you'd be done. You got it. It's right here. Now, what if the question asks you for slope-intercept? Does that mean you got to go all the way back to the beginning and start over, and now we got to try and find that y-intercept? Or what could I do instead? What would be negative 3? Nope. Because the y-intercept is going to be wherever this point is right here. Okay? So this has a y value of 3 up here, so it looks like it's like 1.5 maybe, somewhere in there, but we're not sure. So trying to get it off the graph I can't do, but I can do something with this though. Yeah, we just work this one out and solve it for y. Okay, we can do a little algebra to it, do a little distributing and moving some things around so that it looks the way we want it to look, right? So the first thing I have to do is I need to distribute that negative 4/5. So we got a little fraction work we're going to have to deal with here, but we can do it. So y minus 3 equals negative 4/5 x, and then negative 4/5 times 2. Think of this as 2 over 1. So 4 times 2 is 8. 5 times 1 is 5, so it's negative 8/5. Okay, and then I got to add the 3 over to finish it up, right? Solve that thing for y. So if I add a 3, I've got y equals negative 4/5 x. 8/5 plus 3. How many fifths is 3? 15. Yeah, so it's 15 fifths. But I'm going to add that to negative 8/5, so 7/5, right? So plus 7/5. If you need to go off to the side to do the addition with your fractions and all of that, if you can't do that in your head, that's okay, all right? That's not something I'd expect everybody to be able to do in their head. But, okay, so what did our y-intercept actually end up being in this one then? 7/5, right? Is that something you think you could look at that graph and tell me? Probably not, right? So sometimes starting in point slope and working your way to slope-intercept is going to be the better way to go. Okay, like in this one. Okay, so that's using the graphs to come up with all of that. We also sometimes are going to want to come up with linear equations for things from data. So if you have like a little table of values, something like that, you can develop an equation that way. So, and some people, when they do these, because they feel more comfortable looking at the graph, will just draw the graph and then use that just like we did, and that's fine. But you don't have to go to all that trouble necessarily. So, I'm actually stealing this out of your textbook here. It's example 2 if you're interested. So it says 2 prom venues charge a rental fee plus a fee per person. The table shows the total cost for different numbers of students at Lakeside Inn. The total cost, y, in dollars for X students at Sunview Resort is represented by the equation. And then they give you an equation. Okay, so which venue charges less per student? How many students must attend for the total cost to be the same? Okay, so let me write down a little bit of what I just said. Okay, so there's this table. This is the Lakeside Inn. So, at the Lakeside Inn, so the number of students we're calling X, and then the total cost, calling y. So they've got this little table here of if there were this many students, this is how much the total cost was, and we got to use that information to answer the question here. So if there was 100 students, the total cost was $1,500 to have their prom there. If there was 125, the cost was $1,800. If they had 150 students, the cost would be $2,100. And if they had 175, the cost would be $2,400. Okay, so that's one venue that they could have their prom at, this Lakeside Inn. Another place, rather than giving them just data like that, information about it, just gave them an equation and said, okay, so the Sunview Resort, maybe run by mathematicians or something, instead said, all right, so if you want to figure out how much it's going to cost to have so many students, just use this little equation instead. So they said y equals 10x plus 600. Okay, where x and y represent the same thing. X would be the number of students, y would be the total cost. So if you know how many students you want to bring to your prom, plug it into that equation, work it out, and y will tell you how much money it's going to cost you then. Okay? So the question is, which venue charges less per student, and how many students must attend for the total cost to be the same? Okay? So that we can kind of compare apples to apples here a little bit, let's take this little table over here, and let's make an equation from that. These guys gave us the equation. They did the hard work for us. But this one over here, we don't know what that is yet. But we can use the data to do it. Okay? Remember on a graph, what did we really need to make an equation? What did I have to have on the graph so that we could figure it out?
2 points.
Essentially just 2 points, right? Slope we needed, but we can get a slope by using 2 points, right? So as long as I have 2 points that I know are on the graph, I can make an equation, whether it be point slope or slope intercept. That's really all I need. So this table right here, it's a bunch of x and y pairs, right? So really, what are they giving you here? A bunch of points, right? They're giving you 4. They're giving you 4 points. It's way more than you need. You only need 2 of them. So we can choose any 2 on the table that we want and use that to make an equation then. So I'm going to go with what I feel like are the easier ones. How about we just pick those 2 points then, okay? And make a slope. Okay, so slope is rise over run. Okay, well, another way of looking at that, rise is changing in the y, right? And run is changing in the x. So another way of looking at this, instead of rise over run, it's the change in the y divided by the change in the x. Yeah, 300 over 25 for this one. Because this change in y was $300, and this change in the x was 25. Now remember I said, though, if you end up with a fraction that you can reduce it, right? Okay, well, 300 over 25, that reduces. In fact, it comes out to a whole number. How many times does 25 go into 300? 12 times, okay? So our slope is actually just 12. Okay. Based on what we have to work with, now that we have the slope, do you think that this is going to be easier using slope-intercept form or point-slope form? Do we have a y-intercept?
No, we don't.
So probably point-slope then, right? Now, what you could do, if you wanted, if you're all gung-ho mathlete, you could take this here, see how there's a little pattern, see how it's going, as you go this way, it's going down by 25s? Couldn't you get it all the way down to 0? Keep following this pattern, see how it's going down by 300 each time? and work this all the way to what it would be, then that would be your y-intercept. And if you want to do that, if you think that's easier, just keep following the pattern until x is 0 and see what you have for y. There's your y-intercept. You could do that. Otherwise, point-slope form works just as well. So that's what I'm going to do. I'm going to, again, choose a point that I want to work with. We know the slope is 12. I'll just pick the first point, 100, 1500 as my point, and then kind of work it from there then. So in point slope, y minus 1500 equals 12 times x minus 100. If I'm putting everything where I'm supposed to there. And then I can do all my algebra again to figure out what is the actual slope-intercept form of that. So y minus 1500 equals 12x minus 1200. And if I add the 1500 to the other side, I get 12x plus 300. So now I got an equation for this resort too, or the Lakeside Inn, rather. So we got two equations we can now do some comparing and contrasting to. Okay? Okay. So it said both of them charge some flat fee to go there, and then it's so much per student after that. Okay? So how do you figure out what the flat fee is before anybody even goes there? Yeah.
That'd be like your, I don't know, what's like your 300 or your 600.
Okay, so it'd be your y-intercept, right? Think about that. If x is 0, how many students are attending your prom? 0, okay? So whatever the equation is equal to, if you plug in a 0, that should be how much you're just going to have to pay no matter what, right? So if I plug a 0 into this or plug a 0 into that, $600 for this one right off the bat, $300 for that one right off the bat, okay? So then how much per student on top of that then? Where do I find that number? It's the slope, okay? If one person attended this, how much am I adding to 600? $10. If two people attended, how much am I adding to 600? $20. So it's $10 per student added to what you started with, right? Down here, how much per student? $12. Okay? So linear equations kind of work that way. If there's some kind of like beginning amount or flat fee or something like that, that's always the y-intercept. And if there's so much that you have to pay or whatever per something, per person in this case, that's the slope. That's always the slope. Okay? So the question asked, which venue charges less per student? Sunview charges less per student. Okay? And then it asks, how many students must attend for the total costs to be the same? So we want the cost to be the same with both of them. What variable represents the cost? The y, right? X is how many people are there. Y is how much it's going to cost. So if I want the cost to be the same, y needs to equal y, right? The y from this equation needs to equal the y from this equation over here. So we have what they're both equal to, right? 10x plus 600, 12x plus 300. So those two things should be the same. Okay? So to answer that second question, we got to do a little bit of work, but we can do it. 12x plus 300 would need to equal 10x plus 600. If we solve that thing for x, remember x is how many students, right? If we solve that thing for x, that's going to be the total number of students where they both end up being the same. Okay? So if you were on like the prom committee or something, this would be the calculation you would want to do. Depending on how many students you have, one or the other might be more expensive. Okay? And let's say you know how many students you have that are going to attend prom, so we want to figure out which one's going to be the better way to go. So do a little algebra on this guy. You guys help me out. What should I start with here? Okay, so minus the 10x. So that leaves me with 2x over here. Okay. Somebody else, now what? Minus the 300, okay. So 2x equals 300. Okay, and then somebody else, last step? Divide by 2. Okay, so that would be x equals 150. So they're going to cost exactly the same if 150 students go. Okay, so let's say that we are going to have 200 students go to the prom. Okay, so then which one is going to be better? Okay, well, take a look at their equations. This one charges more per student. This one charges more right off the bat. So if I have more than 150 students, which one do you suppose is going to be better? It's going to be Sunview, right? They charge you more up front, but as you get more and more and more and more people, you're not really adding as much each time, right? It's only $10. So that 150 is the cutoff point, but as soon as you get above that 150, then these guys start to be cheaper because you're paying less per student on top of that. Does that make sense? It's only $10 more each time rather than $12 more each time on top of the 150. If you had less than 150 students, let's say you only had like 75 that were going to be going to prom, then these guys, the Lakeside Inn is going to be the way you want to go. Okay? So that's how you can do that kind of calculation. But through that example, really what I wanted you guys to take away more than anything else was the process we did right here. Okay? Which really is no different from what we did on the graph, right? It's just finding a couple of points, finding the slope, and getting it into an equation then. Okay? So that's what that one was all about. Okay, lines of fit and lines of best fit. I'm going to quickly hit those so we can finish up, and then you guys can get going on some homework. Okay, so notice how that table was really nice. You guys see the pattern in that table on the last one? Where the one column was going up by the same amount each time, and the other column was going up by the same amount exactly each time. Okay, so if you were to graph those points, they'd be perfectly in a line. Okay, all those points would have been right on that equation of that line, just perfect. Well, sometimes we have some data that looks linear, but isn't exactly linear. It doesn't have every point going right on the line. Okay, and so then what we want to talk about is correlation, or how closely do those points seem to make a line. Okay, they're called scatter plots. You guys have probably seen those before, right? Does that sound familiar, a scatter plot? It's a collection of points that appear to be in the shape of some kind of a graph. Okay, so what we have to do first is create a scatter plot, and then sketch in a line that appears to be pretty close, and then come up with an equation for that. Okay, so I'll give you another example here. So I'm going to just sketch a plot here. And how accurately you can graph with this is very, very important. Okay? So what I'm going to do for this is I'm going to give each of you guys one piece of graph paper before you go today so that you can be a little more precise with it. Okay? So none of the slacker graphs on this one for sure. So in your notes here, just kind of do the best you can. I know we've only got line paper for this, but we'll use the blue lines for our y. And then, like I said, be kind of as careful as you can on the x. We'll try to space those out as evenly as we can. Because what we're going to do here is we're going to just take a look at this and try to kind of guess about where a good line through the points would be. Okay? All right, so plot these points with me. Let's go 1, 1. Then we'll do 2, 3. We'll also do 2, 2. 3, 4. Do 4, 5. As well as 4, 3. We'll do 5, 5. And then 6, 6. And 7, 6. All right, so it should look something sort of like that. Okay, so do you guys see how the points somewhat correlate to the shape of a line? Okay, looks pretty linear, but it's obviously not exactly a line. They don't all perfectly line up. Okay, so on this one, the best that we can do, we can't come up with an equation for this thing. But the best we can do is come up with a line that seems to fit it pretty good. Okay, and so what I would do is take some kind of straight edge. You can use a piece of paper if you want. Yeah, I don't think I have my... Yeah, I don't have that in there. All right, so I'm going to use this. Okay, so we're going to use something that you have that is a straight edge. If you have a straight edge in there somewhere, that's great. But do the best you can for now. I forgot to get the rulers out. So, but let's take a look and see. Are there a couple of points in there that we could choose that if we made a line go through those 2 points, it would pretty well go through the middle of this stuff? Okay, so can anybody give me like 2 points, just kind of eyeballing it, that you think would work pretty well in making what looks like a straight line through the middle of the data? Yeah?
1, 1.
Mm-hmm. 1, 1, 2, 2, and 6, 6. Okay, we only need 2, but that works. Okay, those all happen to line up together, right? So we could do that. Okay, so let's go with, how about 1, 1, and 6, 6. With those 2 points. So why don't you go ahead and circle those 2, and then draw a line going through those. Should look something sort of like that. Okay, so you're doing the point 1, 1, and then when you got them, go ahead and label them like I'm doing. So we're going to work with 1, 1, and 6, 6. And we want to know what's the equation of this line of fit then. Okay, what is the equation of that thing that works the best? So we're going to do just like we did at the very beginning of class today, where we calculate the slope and the y-intercept, or slope and use a point to make an equation. Okay, so looking at those 2 points, what's the rise and what's the run? 5 and 5. You go up 5 over 5. So the slope is 5 over 5, which is just 1. Yep. Okay. Now, looks can be deceiving sometimes. What appears to be the y-intercept here? 0, 0. Yeah, it appears to be 0. So let's verify that, though. Just to be sure, we'll go point slope on this, because one of the 2 points that we picked wasn't actually on the y-axis. So using point slope, I'm going to use this slope, and then I'm going to use the point 1, 1, because that's pretty easy to work with. And let's throw that into point slope form and see what we got. So we got y minus 1 equals 1, that's the slope, times x minus 1. And we'll just do a little algebra, distribute, and move things around, see what we got. So y minus 1 equals x minus 1. So if we add 1 to each side, y equals x. Okay, so what was the actual y-intercept then? It is 0, yeah. So the y-intercept really is at 0, because this is technically y equals 1x plus 0. We just don't write the 0 on there. But that would be our equation of fit for that, y equals x. Okay, so now does that mean that that's the best line we could have drawn through the data? Not necessarily, okay? And to be able to do that by hand is really tedious. So we have graphing calculators that can do the work for us. They can find the absolute best line that would fit all of that stuff, okay? So I'm going to show you guys how to do that. So if you would, take out your graphing calculators and follow me. Here's what we're going to do. First things first, we need to take this data and put it in our calculator, okay? How much time do I have? Okay, we're good. Okay, so we're going to take this data and put it in the calculator. So every one of these points, I need to put in a table real quick, okay? So let's do that. Make a little XY chart. Okay, so we had the point 1, 1. That was the first one we circled. Then we had 2, 2, and 2, 3. And then we did 3, 4. Next ones we did were 4, 3, and 4, 5. Then we had 5, 5, 6, 6, and 7, 6. All right, so we had 1, 2, 3, 4, 5, 6, 7, 8. We had 9 points altogether there, okay? So we have to tell the calculator all of those points, okay, where they are. So here's how we do that. See the button that says Stat? It's right in the middle-ish there, next to the arrows. Go ahead and hit Stat. You're going to see this menu. And where it says Edit, go ahead and hit Enter. And you're going to see some lists in here. And there might be some numbers already in there, like on mine. Okay? And if you want to get rid of what's in there, you can move things around here. So if you go up to the top of the list, so where it says like L1 or L2, don't hit Delete, hit Clear. Delete will get rid of the entire list. We just want to get rid of what's in it. So just hit Clear, and then hit Enter. And list 1 is still there, but there's nothing in it now. Okay? Same thing with list 2. If there's anything in there, Clear, Enter. Okay? It's really just L1 and L2 that we need to work with here. Okay? So here's what we're going to do. L1 is going to be X. L2 is going to be Y. So that table that we just made, we're just going to type the numbers in for those two lists. So L1, I'm just going to go 1, 2, 2, 3, 4, 4, 5, 6, 7. All those X values just straight down. And then I can hop over to L2 and do the same thing with the column that we had for Y. So I had 1, 2, 3, 4, 3, 5, 5, 6, 6. So now you've told the calculator what are all the points you want to work with. And now we got to go back and tell it to tell us this line of best fit. What's the equation of it? Okay. So does everybody have the data in there then? Before I move on, don't leave anybody in my dust here. So, all right. So to get out of this little list, you just hit second and then the mode button, which is quit. It'll take you back to the home screen. Then we're going to go back into Stat. But this time, instead of Edit, we want to go over to where it says Calc. So use the little arrow to move over to Calc. All right. And then you're going to go down to number 4. Which says LinReg, which stands for Linear Regression. Regression is kind of a fancy term that just means of best fit. So it is a linear equation of best fit or linear regression. Okay, so hit number 4, and then it's going to paste this up at the top. You hit Enter one more time. Okay, and you might see all of these things, but really all you need is the A and the B. Okay, because look right up here. See how they have y equals ax plus b? Looks really similar to mx plus b. They're just using an a instead of an m. It's the same thing, okay? So what is the slope of this line?
8.1. Oh, it's 0.81.
Right, it's the 0.8169, etc., etc. What's the y-intercept of this line? The 0.8028, blah, blah, blah. So you don't need to write the big old decimal, but at least like 3 or 4 decimal places, and I'll know that you got it, okay? So the line of best fit for this would look something like this. Y equals 0.81, let's see if I round it, it would be 817 x, and then 0.803, so plus 0.803. Okay, so let's do a little comparison here. We came up with y equals x. What was the slope of our line? 1. What's the slope of the actual best line? 0.817. We were pretty close, right? That's only off by 0.2. It's not shabby. Our y-intercept we came up with was 0. The actual y-intercept, 0.803. Again, off by 0.8, less than 1. Not bad, okay? So we were able to eyeball something that was pretty good, but it wasn't perfect. This one is the perfect one, okay? So, all right, so that's all the stuff I'm going to expect you guys to be able to do in your homework, so I'm going to get you guys going on that. And that will be due tomorrow.